Here we have a math problem in Algebra 2. Okay, let's go over the question. Let the function f be defined by f of x equals to square root of 50 negative 2x square. What are all the values of x for which f of x is a real number? Okay, according to the question, this f of x has to be a real number, so that we have to find the values of x. Okay, here we have f of x equals to square root of 15 negative 2x square. Okay, here we have square root. Inside the square root, when we have a negative number, then the square root will be considered as imaginary number. That is, if the value of this 15 negative 2x square is a negative value, then this is imaginary. Since this is equal to f of x, then f of x also will be considered as imaginary. But according to the question, f of x has to be a real number. If I want this f of x has to be a real number, then the value inside the square root over here, that is this 15 negative 2x square, can be 0 or greater than 0, so that it will be a real number. Then the f of x will be a real number, so that we have to find the values for x. So according to the question, this stuff, the value we have inside the square, that is 15 negative 2x square, has to be greater than or equal to 0, so that it will be a real number. Now we have to solve for x in this inequality. Okay, here when I consider the expression on the left side over here, both the terms are multiples of 2, so we can factor 2 out. If 2 is factored out, then we get 25 negative x square inside the parenthesis over here, greater than or equal to 0. Now to get rid of the 2 which is multiplied over here, let me divide both sides of this inequality by the same positive value, that is 2. Okay, here this 2 will cancel out, then I'm getting 25 negative x square greater than or equal to, when I divide 0 by 2, I'm getting 0. Okay, here on the left side, the variable x is having negative sign. Okay, now to make the sign of the variable as positive, let me multiply both sides of this inequality by negative 1. Okay, let me do it. That is negative 1 times 25 negative x square. And also on the right side, negative 1 times 0. Okay, whenever I multiply both sides of an inequality by the same negative number, or whenever I divide both sides of an inequality by the same negative number, I have to flip the inequality sign, because here I multiply both sides of this inequality by the same negative number, that is negative 1. So when I flip this inequality sign, I am getting less than or equal to. Okay, now I can distribute this negative 1 to this 25 and negative x square. When I do so, I am getting negative 25. Negative times negative will become positive. 1 times x square is x square less than or equal to. When 0 is multiplied by any value, still it is 0. Okay, here we can write this positive x square at first, then we get positive x square, then we can write negative 25 less than or equal to 0. Okay, now let me continue the problem over here, x square negative, and we can write this 25 as 5 square, okay, less than or equal to 0. Now let me consider an algebraic identity, that is difference of two squares, a square negative b square. Okay, whenever we have difference of two squares in this form, it can be written in the factored form, that is a positive b times a negative b. Okay, here the expression x square negative 5 square is exactly in this form, a square negative b square. So comparing this and this, we get x at the place of a and 5 at the place of b. Since this is in the form of a square negative b square, we can write this one in factored form, like a positive b times a negative b. So for a, we have to write x, and for b, we have to write 5. That is, for a positive b, we can write x positive 5. And for a negative b, we can write x negative 5 less than or equal to 0. Okay, now let me assume this inequality as an equation, that is x positive 5 times x negative 5 equals to 0. That is, it's just my assumption. Okay, here the product of two binomials is equal to 0. Since the product of the two binomials is equal to 0, so the first one must be 0, or the second one must be 0, or both of them may be 0, so that the product can be equal to 0. If the first one is equal to 0, then we get the equation x positive 5 equals to 0. Or if the second one is 0, we get the equation x negative 5 equals to 0. Okay, now let's solve for x in this equation. For that, we have to subtract 5 from both sides of this equation. Then positive 5 and negative 5 will cancel out. I am getting x equals to negative 5. Okay, here let me add 5 to both sides of this equation. Then this negative 5, positive 5 will cancel. I am getting x equals to 5. Okay, now let me mark these two values of x on the number line. Okay, here on this real number line, we have negative infinity on the left side extreme, a positive infinity on the right side extreme. And we have to write these two values in order. So we'll have negative 5 first and positive 5 next. Okay, so here we get three intervals from negative infinity to negative 5, negative 5 to positive 5, and positive 5 to positive infinity. Now we have to check all these intervals one by one with this inequality. That is to find the interval which satisfies the inequality we have over here. Okay, now let's choose a random value in the first interval over here. So probably we can choose negative 6. Okay, when I plug in x equals to negative 6 in this interval, what will happen? When I plug in x equals to negative 6 over here, negative 6 positive 5 will become negative 1, this factor, I mean this binomial. When I plug in negative 6 over here, negative 6, negative 5 will become negative 11 less than or equal to 0. When I multiply negative 1 and negative 11, I am getting positive 11 less than or equal to 0. We cannot accept this because it's a false statement. A positive value less than or equal to 0 is not true. So the value I took in the first interval between negative infinity and negative 5 does not satisfy this inequality. Okay, now let me take the second interval, negative 5 to positive 5. Let's choose a random value in this interval, say 0. Okay, when I plug in x equals 0 over here, then the value of this binomial will become positive 5. And when I plug in x equals 0 over here, the value of this binomial will be negative 5 less than or equal to 0. Positive times negative is negative, negative 25 less than or equal to 0. Actually, it is a true statement because a negative value is less than or equal to 0. We can accept it. So the interval negative 5 to positive 5 satisfies this inequality we have over here. Okay, now let me take a random value in the third interval, that is between 5 and positive infinity. Now let's choose a random value, that is 6. When I plug in x equals to 6 over here, 6 positive 5, 11. And when I plug in x equals 6 over here, 6 negative 5 is 1. So clearly it's a positive value. Positive value less than or equal to 0, it's not true. So we can reject the third interval as well. Okay, so when I take a random value between negative 5 and positive 5 in the second interval, it satisfies the inequality over here. And also we have to check the boundary values of this particular interval, the middle interval. So that is we have to plug in this negative 5 in this inequality and check whether this boundary value, the left side boundary value, satisfies this inequality. When I plug in x equals to negative 5 over here and here, so negative 5, positive 5, this one will become 0. And here negative 5 will become negative 10 less than or equal to 0. 0 multiplied by any value is still 0. 0 less than or equal to 0. Actually, it is a true statement because here we have less than or equal to. That is the value we have on the left side, the value we have on the right side can be equal. Otherwise, the value we have on the right side has to be greater. Anyways, since we have the option, both of them can be equal. 0 and 0 are equal. So the boundary value, the left side boundary value, negative 5 satisfies this inequality. Okay, now let's verify the right side boundary value, that is positive 5. Okay, when I plug in x equals to 5 over here in this binomial, 5 negative 5 will become 0. When 0 multiplied by this value, again we get 0 less than or equal to 0. It's a true statement because 0 less than or equal to 0. There is an option equal. So both the boundary values of this interval satisfy the inequality over here, and also the value we have in between negative 5 and positive 5 also satisfy this inequality. So the value of x in this can be considered as negative 5 less than or equal to x less than or equal to positive 5. So when x takes any value from negative 5 to positive 5, the value we have inside the square root, I mean the value of this expression inside the square root will be positive, then it is a real number, then f of x will be a real number. So f of x is a real number. So when x takes a value from negative 5 to positive 5, and we find this stuff exactly in answer choice D, the correct answer choice for this question is D.